This is GCSE Maths. We are looking at statistics, and this is Unit 18 in the accelerated course. So we're looking at sampling techniques. So just some information then that you should be aware of. The population, first of all, is the complete set of data. It is often impossible or impractical to ask everyone. A sample of the population then would be taken. So if we want to find out, kind of people in Northern Ireland, whether they like, hockey or not, it'd be quite tough to ask everyone in the country. So you take a sample and try and keep it as fair as possible. So the sample must be large enough to make the results meaningful, as in, don't just ask the person beside you, do you like hockey? And if they do, then everyone likes hockey. That doesn't make any sense. Representative of the complete data set. If I go down to a hockey club and ask if you like hockey, loads of people are going to say yes, and it's going to give an unfair, biased representation of what it is. So you need to be very careful taking your sample that you kind of ask everyone. Again, if you kind of ask people in school, make sure and take a sample of both male and female, and at the same time take ones from different year groups as well. So different things you need to be careful with taking the sample. So representative of a complete data set. Unbiased, every piece of data has an equal chance in it being chosen. So types of sampling: random sampling. This means that the sample is chosen completely at random. I can get this straightened up very slightly. Completely random. Positive, all data has an equal chance of being chosen. Negative, no guarantee that the data in the sample would be representative of the population. So that's their kind of pros and cons of random sampling. Systematic random sampling. Data is chosen at random according to some rule, e.g. every sixth item. Positive, all data has an equal chance of being chosen. Con for this one then is no guarantee that the data in the sample would be representative of the population. Stratified random sampling, this one's used a lot. This method ensures that the data will be representative of the population by dividing the population into separate groups and choosing data sets from these groups in the same proportion as the population. This is statistically the best method of sampling. Positive, all the data has an equal chance of being chosen, and the data in the sample is representative of the population. Say, for example, this is what stratified, it's not as complicated as it sounds up here. Say I have a class of 30 pupils and I want to take a sample of 6 out of that, so I'm taking 1 in every 5. Say there happens to be 20 girls and 10 boys. To me, it would be unfair to take 3 and 3 because there are more girls than there are boys. So a fair way of doing this is to use stratified random sampling, and because there are twice as many boys as girls as there are boys, we would pick 4 and 2, and that's how you kind of stratify the random sample. And so you pick 2 random ones for 4 random girls and 2 random boys, and then that keeps it fair as a representation of the way the pupils are split in my class. Hopefully that makes sense. So on then, there are a couple of examples. We'll see how we get on. Stratified random sampling. In this method, the sections in the sample are kept to the same proportion as the sections in the full, e.g. a fifth of the school population is year 8, then a fifth of the sample should be year 8. Just exactly what I was saying there with my class. E.g. a DVD rental company, goodness me, whatever that is, classified its stock as follows. So there's a different DVDs it has. A sample of 80 is taken to find the condition of the DVDs. What would the sample consist of to ensure a fair representation? So let's first of all work out our total, see how many we have. So that's 67 plus 128 plus 59 plus 146, so 46, right? 67 plus 128 plus 59 plus 146, and that comes to 400. So a sample of 80 is taken. What should the sample consist of to ensure as fair a representation as possible? Can you see if we're taking 80, we're going to take 1 in every 5. So we're just going to take a fifth of these, a fifth of these, a fifth of these, and a fifth of these, and be careful that it adds into 80. So comedy is going to be then 67 divided by 5, which gives me 13.4, I think. I don't quite trust myself, I'll just check that. 67 divided by 5 is 13.4. Drama. It's 128 divided by 5, or if you want the fifth, I mean you can multiply by 80 over 400, I guess is another way of doing this. So 128. That gives me 25.6. Foreign 59 divided by 5 gives me 11.8. And then other is 146 divided by 5. Which is then 29.2. So what I would take then would be 13 of these, I would take 26 of these, I would take 12 of these, and I would take 29 of these, and I'll now check that it adds up correctly, because just the way you round, sometimes it doesn't always work out. But if we have 13 plus 26 plus 12 plus 29, and it does give 80. So we're okay, that's worked out all right. If it doesn't, you just add on one to another one. All right, say it comes to 81, then we would change that from a 26 to a 25, because this is the important bit, is if you're taking a sample of 80, it needs to be 80 DVDs, and so it's a bona fide method just to kind of change that. As weird as it sounds, you might round down whenever you're supposed to round up with the most sensible one. So that then is our example 1. Take a look then at example 2. A stratified sample was taken of the men, women, boys and girls on a cruise. There are 21 men, 19 women, 7 boys and 8 girls. That's in the sample. There were 798 women on board. How many men, boys and girls were on board? So if we then do 21 plus 19 plus 7 plus 8, so we turn it on. 21 plus 19 plus 7 plus 8. That means the sample size then was 55. Not quite sure what I've done there. Okay, there were 21 men. There were, oh sorry, I've made a mistake, sorry. Right, goodness. Apologies. You need to read the question carefully. Sorry about that. There's a minute of your life wasted. There were 21 men, 19 women. There's 798 women on board. So it's 798 divided by 19. 798 divided by 19. And it gives me 42. That means effectively they've picked 1 in 42 people. So if that was for the women, for men, then to work out how many we're going to have, we would have to do then 21 times 42, which is 882. Boys, it's going to be 7 times 42, 194. Girls, it's going to be 8 times 42, 336. That's the answer to the question. So you see what I've done, because we were given women and we were given the women here, and we were given the women here. If I divide 19 into the 798, that must have taken 1 in 42, and that gives me my fraction. And so 42 is my magic number to multiply up through, and that gives me the values then that I need. Okay. Finally then, example 3, 456 vehicles passing the junction were cars, 266 lorries, 76 were motorbikes. Stratified the sample to taken, which is 12 were cars. How many lorries and motorbikes are in the sample? So very similar to the previous one. We want to do 456, this is for cars. 456 divided by 12. And it gives us then 38. So that means lorries, we would need to do then 266 divided by 38, because that's how many there were in total, so we need how much is in a sample. It looks like it's taken 1 in every 38. It's 266 divided by 38, that's a 7. And Then motorbikes, it's going to be then 76 divided by 38, which obviously then gives us 2.